Hey, are you ready to do some math today? You better be, because you have to. All right, that's enough.
Okay, thanks, Strong Bad. If you are here for lesson 51, simplifying rational expressions with like denominators, you're in the right place. Good morning, afternoon, whatever time it is when you're doing this ridiculous stuff that you're doing. It's time to do some math. All right, you're going to need a few things with you today. You're going to need a pencil, eraser possibly, but yep, you're going to need some scratch paper, or maybe you're going to need, oh, you might need this today. That was in that email that I sent you. And you're going to need to print out some of the homework paper. Yeah, because you're going to send that back to me at some point so you can get a grade. That should be it. Plus, I guess if you're going to be taking notes, and you should be, you need some type of binder or a notebook to keep notes in. Whatever you put down on here, you can use on the test, so that would be a good idea. All right, let's get started. Our problem today is to take a rational expression with like denominators and make it simpler. Okay, we're gonna make things simple. Simplify, simplify, simplify. I need to define a few terms for you first. The first one of those is rational. You know what that means? Does it mean just like things make sense? Not in math, it doesn't. Rational always has to do with this part of the word, ratio. And so rational is talking about fractions. Okay, so anytime you see the word rational, you need to think fraction. Second is expression. Expressions could be like this, or. But in math, expressions mean something without an equal sign. It could be anything, as long as there's not an equal sign. That's the difference between an expression and an equation. Expressions do not have equal signs. They're just some math all by itself. So even just 3 plus 2 is an expression, doesn't have an equal sign, so it's not an equation. Or 2x over 7 is an expression. Sometimes these can be simplified. They can be put in a simpler form. They can be put in a new form that's equivalent, that's easier to work with. And that's usually what we have to do in math, is we have to take something that's more complicated and boil it down to just what we need to know and put it in the form that's the easiest to work with, what I like to call the math of least resistance. Okay. Third, like denominators, since we're dealing with fractions, we're talking about how we combine fractions, which means adding and subtracting primarily, at least first. And so the trick there is that we're able to combine fractions or add or subtract fractions that have the same denominator. And it says like denominators, and that's kind of a misnomer. You start to think, well, they're like each other kind of because they're both numbers. But no, it actually means that they have the same denominator, because if they have the same denominator, you can combine them very quickly. So let me give you a few examples of that. We'll do it with numbers, and then we'll do it with variables. We'll do it with letters and things like that. So we could take something like 1/5 plus 2/5. Okay, if you know the rules for fractions, and the rules for fractions are on that reference sheet, you know that if they have the same denominator, you can just combine the numerator. That this problem turns into 1 plus 2 over 5. You can't do it the other way around if the numerators are the same, but you can do it if the denominators are the same. 1/5 and 2/5 is 3/5. Just think about a pie chart, or filling in boxes in a rectangle. That's the way that it would work. So this only works if the denominators are the same. If the denominators are different, you have to then find a common denominator and adjust the numerators so that you can put them together. Now today we're not just doing fractions with just numbers. We're going to throw in variables in there. If you remember, a variable is something that could take on any value in an equation. And sometimes you're just waiting for somebody to tell you what x equals so you can plug it in. But for now, we're not going to worry about that. We're just going to move things around with the variables in there. And the problem today is that the variables are going to be in denominators. It'll be something like 2 over x. Just a normal expression. It makes an interesting graph. But there's a problem with that. If we have something like that, or even 3 plus 2a over a minus 3. The problem comes in when a, or whatever the variable is, takes on a value that makes the denominator equal to 0. Dividing by 0 is one of the big problems that you have in mathematics. In fact, today we'll look at some techniques to get around some of that if we can, if it's set up the right way. But in general, if that denominator, if that letter there takes on a value that makes this denominator equal 0, bad things happen. Okay, and there's really no way to get around that until you get to calculus. Like, it's a problem that stays with a mathematician all the way until they get to calculus. And when they get there, you learn a strategy for getting around that problem. Okay. So here's what you got to do. You gotta find what's called a restricted value. That is, a value for that variable that you cannot use because it would make the denominator equal to 0. Do you want to see what happens if you try to divide by 0? Okay, hang on just a second. This is what could happen. Like, a hole will open up in the universe and swallow things. It's messy. I've seen it before. You don't want to go there. So in this expression right here, what we'd want to do is say, okay, what happens when x equals 0? That one's pretty obvious. 0 is a restricted value. You cannot use that. Any other number will give you a rational expression. That's fine, that you could use any time. For this one here, we're looking for when a minus 3 equals 0. And then we just do the math here. We add 3 to both sides. So when a equals 3, that's a restricted value. We could write it like this. A cannot be 3. Okay. It doesn't matter what makes the numerator 0. If we looked at that right here, we said, well, what happens when this is true? Nothing. Like, the numerator will be 0, but the denominator wouldn't be. So it'd be 0 divided by something. And you can always divide 0 by something and still get 0. But here we'd have a equals negative 3 over 2. If you plug that value in there, it would make this whole thing equal 0. But the bottom wouldn't be. The bottom would be a negative number, and that's okay. So we really only care about what happens down here. We're looking for when that equals 0, and then that value will be a restricted value. Your solution cannot include that number. We're not allowed to put that in because then we're trying to divide by 0. Okay, so let me give you a couple of examples of problems out of the book that they'll say, here's what we can do. Okay, there's a couple of things we can do if it's set up right to start to avoid that kind of thing and to break this down and to make it simpler. So I'm going to hit pause and put a couple of problems up on the board, and then we'll go from there. You can always hit pause too and go back and watch a little bit of this again if you're writing things down in your notebook, which you are. You can always hit pause and rewind and see those things again. Okay? Okay, I'm back. Here we go. I know it's like shiny right there. I'm sorry about that. I have to have light. Skill number 1. Simplifying by factoring first. Factoring means a sort of division, of pulling apart of the stuff and seeing where the pieces are. And if we have a piece in the numerator and a piece in the denominator that are the same, that part there is equal to 1. Anything divided by itself is 1. So that's what we want to do. We want to find if there's anything in there that's the same in the top and in the bottom that we can cancel out because it's equal to 1 and it doesn't matter. So here, if we kind of pull it out into its factors, we try to figure out what's in both of them. And we have 8 is 2 times 4, and 12 is 3 times 4. So I'm going to write it like that. I got 2 times 4. I've got 3 times 4. And then here we have 2 h's, and in the denominator we have 1 h. So anytime we have the same thing in the numerator and denominator, like 4 over 4, that equals 1, so that can cancel out. And we have an h over h, and that can cancel out. And all that leaves us with is 2h over 3. So we solved the problem because now we don't have to worry about what h can't be because there is no h in the denominator anymore. In the original equation, if h was 0, we would have a problem. But now we don't worry about if h is 0 because that would just be 0 divided by 3, and we solved our problem. Second one over here, it says we're supposed to factor first, and there's no factoring to be done in the denominator, but I can factor in the numerator because the factor 2 is in both pieces, in both terms, this term and that term. So if I factor a 2 out, I'm left with m from the first term, and 3 times 2 is 6, and there's my denominator. Now, these are factors, they're multiplied by each other, and then fractions is just a fancy way of dividing. So this is multiplication and division, and these can cancel out because they are like each other. If you want to think about it like that, you can put it like that, and you can see m minus 3 and m minus 3 in the top and the bottom. So this expression is equal to 2. Now there's not even a variable there. That's much simpler. I don't have to worry about any restricted values for that type of problem. Now I'm going to go and put a second skill up on the board here, and then we'll be done. Okay, here we go. Last round. Skill number 2. Add, subtract rational expressions easily if you have the same denominator. A lot of these look like they're the same. This one looks the same with numbers. This one looks the same. This one looks the same. This one does not. We're going to have to fix this one. We'll get to that. So just like we started off with numbers, if they're fractions, rational expressions, if the denominators are the same, we can just add the numerators. 1 plus 3 is 4. This equals 4 over 4, and that equals 1. This is the exact same problem, except I've replaced 4 with x. Okay? I have 1 compared to x and 3 compared to x, and that means I can go 1 plus 3 over 1 denominator, the same denominator, x, and I can have 4 over x. Okay, piece of cake. These ones both have a cubed in the base of the denominator, so my whole answer is just going to be like that. And the top, I can just combine those two. B minus 2b, 1b minus 2b is a negative 1b, and that one's done. This is the only one that's tricky because it doesn't look the same as it is. But you notice that there's some negative exponents, and negative exponents mean reciprocals. That means we need to take that fraction and turn it upside down. So this one turns into p over, the q drops down here, and we change the exponent to a positive 2. And then this piece right here, that 7 stays up top. This p needs to go up to the top and change its sign to the 1. And this q stays down there. And now we have the same denominators, and we can combine the numerators. So this will equal p minus 7p over q squared. And you can just leave it like that because we've combined these things and we have one denominator. There you go. If you look in your book at example 4, really you just have a couple of tools here to try to apply. And I always say to take the math of least resistance, it would be a better idea to cancel first and then combine. If they don't look the same, try to find some way to make them look the same without cheating or breaking the rules of math. Okay, that's all for this lesson. We'll see you in the next episode.